Okay. Shh. So first of all, ladies and gentlemen, let's talk about what an identity is. When you have trig functions that have numerous relationships, in other words, I can take an expression and by other formulas and substitutions, there's numerous ways I can write equivalent expressions. So when this happens, we call this an identity. An identity is an equation that is true for all variables. All right. Now remember, typically angles can be expressed as the following. We can express angles with a lot of different variables. You've been introduced to one particular variable, which we've called theta. That's just a variable that represents an angle measurement. You may also just see x. You're going to be introduced in this particular chapter other variables to represent angles. Looks like half of an infinity symbol, which we call alpha, which looks almost like an uppercase B, which we refer to as beta. So just like theta, we've got these other two Greek symbols. They are variables that just simply represent a variable, but it's an angle measurement. So x, theta, alpha, beta, just different ways that we can use a variable to represent an angle measurement. So the first couple identities that we are going to talk about, which are on your blue sheet, which you probably already know, are what are called your reciprocal identities. And they're right here on your blue sheet under number 1. These are your reciprocal identities. So it's just another way that we could write sine. We know sine and cosecant are reciprocals of one another. So sine is equal to 1 over cosecant. Cosine is equal to 1 over secant. Tangent is equal to 1 over cotangent. Cosecant is equal to 1 over sine. Secant is 1 over cosine. And finally, cotangent is equal to 1 over tangent. So those are your reciprocal identities. So like I said, sine of x is equal to 1 over cosecant of x. Cosine is equal to 1 over secant of x. Tangent is equal to 1 over cotangent of x. Cosecant is equal to 1 over sine of x. Secant is 1 over cosine of x. And then cotangent is equal to 1 over tangent of x. So any powers are valid for reciprocal identities. What that means is that if you have sine squared of x, so if sine is being raised or one of your trig functions is being raised to a power other than 1, then you can also apply your reciprocal identities as well. So sine squared x would be 1 over cosecant squared of x. So even though it may be a different power other than 1, you can use the different powers for reciprocal identities. Just a notation which I mentioned back in Unit 1. When you see the quantity of sine of x to the second power, you can write that in a different format. Sine of x squared. So somewhere along the way, some mathematician got lazy along the way and decided they don't want to write these parentheses all the time to the second power. So instead of seeing this parentheses sine of x squared, what you're going to see is the sine squared of x. That's what this, when you see these trig functions raised to a higher power other than 1, you need to remember that this is actually equivalent to the quantity. It's the parentheses are around the sine of x and all that's being raised to the second power. Again, it is not equal to sine of x squared, sine x squared. In other words, you're not just squaring whatever angle that is. Okay. So like I said, you should be a little bit familiar at least with those reciprocal identities. The next one, which we've talked about, especially when we were studying the unit circle back in Unit 1, quotient identities. And that's under number 2 on your blue sheet. So the quotient identities is where you can take tangent and rewrite it into sine over cosine. So remember, tangent is equal to sine over cosine, or remember y over x. Cotangent is the cosine over sine. So those are your quotient identities. So tangent of x is sine of x over cosine of x. And then cotangent of x is the cosine of x over sine of x. Okay. Just like with your reciprocal identities, any powers are valid for your quotient identities. So for example, if you see that you have the tangent to the third of x, tangent to the third of x is equal to sine cubed of x divided by cosine cubed of x. So it applies for your higher powers. All right, so those are the first two on your formula sheet. Probably the biggest new one in here are your Pythagorean identities. And yes, you're familiar back from geometry with your Pythagorean theorem. And actually, these Pythagorean identities in trig does derive from the Pythagorean theorem that you learned back in geometry. The primary Pythagorean identity is the sine squared of x plus cosine squared of x is equal to 1. That's probably the one formula that we use over and over again. Comes up a lot in calculus. It's just one of those very common identities that we use a lot. And again, this does come from the Pythagorean theorem and from your unit circle. Remind me again, what is the unit circle? The unit circle has a center at 0, 0, and what else? What do you know about a unit circle? We know the center's at 0, 0. What do you know about the radius of the circle?
It's 1.
It's 1, exactly. So again, when we're talking about the unit circle, remember we have a hypotenuse of 1. And again, we drop the triangle. So remember, guys, back from geometry, when you've got your Pythagorean theorem, we know we had a squared plus b squared equals c squared, correct? So now remember, going back to what we talked about back in Unit 1, remember, what trig function was x equal to? X was equal to what trig function? I know we had a snow day, but x is equal to what trig function? Cosine. Remember, x is equal to your cosine of x, correct? Y was equal to what trig function? Sine of x, exactly. So remember, when we have a point on the unit circle, we know that this point is x comma y. So now remember, this horizontal side of the triangle is equivalent to x. The vertical side, remember back from Unit 1, was equal to the y coordinate. So going back to your geometry days, using your Pythagorean theorem, if I had this triangle set up, what is, by your Pythagorean theorem, this going to be equal to? It would be equal to what? So be equal to what? X squared plus y squared equals 1. Exactly. So now if I substitute, what did you tell me a few minutes ago that x was equal to? X was equal to what? Cosine. And y was equal to what? Sine. Very good. So then I can rewrite this as your cosine squared of x plus sine squared of x is equal to 1. And that's where that first Pythagorean identity comes from. All right? So it is based upon that Pythagorean theorem that you learned back in geometry. Sine squared plus cosine squared is equal to 1. Now, you can derive other forms of your Pythagorean identities from this one. As long as you remember, guys, sine squared plus cosine squared is equal to 1, you can find the other two. And you guys will remember sine squared plus cosine squared equals 1 because we're going to be using it over and over again. This is the way, instead of having to memorize all these different formulas right here, this looks very overwhelming because there's actually 9 different variations of this Pythagorean identities. So as long as you follow these steps, you don't have to sit down and memorize all 9. Just know this one. If you know that one, you can find all the others. That's the key. Make sure you memorize sine squared plus cosine squared equals 1. Now, how how can you come up and find all these others? So let's just suppose I take my sine squared plus cosine squared equals 1. Let's divide this whole thing by cosine squared x. Is that legal? Am I allowed to take an equation and divide everything by cosine squared? Is that legal? Yeah. Yes. By properties of equality, I'm allowed to do that, aren't I? So now, let's simplify. What is sine squared over cosine squared? Well, what trig identity did we talk about a few minutes ago where sine over cosine? What's sine over cosine actually equal to? Tangent, exactly. So I know that this is going to be equal to tangent squared of x plus. Now, what's cosine squared divided by cosine squared equivalent to? 1. So tangent squared plus 1 is equal to 1 over cosine squared. I just showed you those reciprocal identities. Well, what trig function is the reciprocal of cosine? Secant. So then 1 over cosine squared is going to be equal to secant squared of 1. So there's your second one, which is what comes right there. You don't need to memorize them. Just remember, divide the whole thing by cosine. You can find the other one. So any questions on that one? So now, instead of dividing, remember, going back to that very basic original Pythagorean identity, the sine squared plus cosine squared equals 1. Instead of dividing the whole thing by cosine squared, let's see what happens when you divide the whole entire thing by sine squared. So what's sine squared divided by sine squared going to be? 1. Plus, what's cosine squared divided by sine squared? Cotangent squared by your quotient identities. And then 1 over sine squared is going to be equal to what? Cosecant squared. So there is your third and final Pythagorean identity. So notice, you don't have to memorize all of them. All right? You do not have to memorize all of them. And you don't want to have to memorize all of them. Just remember, as long as you remember sine squared plus cosine squared equals 1, you can find the other 2. All right? There's so many interrupts going around, we don't know. He's an interrupt somebody said. Anyway. Sure. Just to come in on a Friday. What'd you do, Case? What'd you do? No, he's from Central. So he's from Central.
Who's the other guy with him?
Mr. Davari?
Yeah, like Mr. Davari, and then who's the other guy?
He's from Central Office somewhere. He's interim superintendent. Huh? Miss Goss?
Our principal got locked up.
We're going to need another hand pretty soon to start counting how many principals we've gone through. Because I think we're on number 4 in under a year, I think. Yeah. So we're going to run out of a hand pretty soon. I said, well, I don't know if you don't see me next week, you know I must have done something. If you don't, I obviously didn't pass that test, so who knows? Okay, guys. Now, ladies and gentlemen, so where these other alternate forms come from, again, going back to sine squared plus cosine squared equals 1, algebraically, you can manipulate this one equation and come up with other forms. In other words, if I want to take this, again, my original sine squared plus cosine squared equals 1, solve for sine squared, I would subtract cosine squared on the other side. That's where that 1 minus cosine squared comes from. Or I can do the same thing, solve for cosine squared, I can subtract sine squared on both sides. So these alternate forms are just coming from algebraically manipulating those 3 original ones. All right? Again, any form of the Pythagorean identity may be used, meaning like if you solve for it. Now remember, just some common errors. Sine squared plus cosine squared equals 1 is changed to sine of x plus cosine of x equals 1. That's a no-no. All right, you can't just take the square root. Or if you've got sine to the third of x plus cosine to the third of x equals 1. Pythagorean identities only work if you've got the squares. All right? So when you talk about these Pythagorean identities, again, any three versions apply. In other words, group the two trig functions that go together. Sine squared and cosine squared of x go together in your Pythagorean identities. Tangent squared and secant squared go together. The c's go together. The cotangents and the cosecants. So I call this the c's that go together. So just remember which trig functions go with which identities. Sines and cosines go together, the Pythagorean identities. Tangents and secants go together. The cotangents and the cosecants are good. Okay? All right. Now, this is I'm going to show you the hexagon next class. This is just a trick to help you remember your Pythagorean identities. Even odd functions you guys have already talked about. Remember, as I mentioned from the last unit, the last 2 units, there's only 2 even functions, cosine and secant. Remember, cosine of x is equal to the cosine of negative x. Secant of negative x is equal to the secant of x. So remember, there's only 2 even functions, cosine and secant. The other 4 are odd. Remember the algebraic definition for odd functions. Sine of negative x is equal to negative sine of x. Tangent of negative x is equal to negative tangent of x. Negative cosecant of x is equal to the cosecant of negative x. And then we've got the cotangent of negative x. Just like with the reciprocal and quotients, any powers are valid for even and odd identities. So in other words, cosecant squared of negative x is equal to the negative cosecant of x, all being raised to the second power. Okay. So, like I said, these are your even and odd. So on your blue sheet, these are your even and odd identities. And these are the 4 that we're going to work on today. All right. Now let's let the fun start. So now, ladies and gentlemen, first of all, just for you to get some practice in, what I want you to do is fill out these first 10 by these different identities, telling me what these different trig functions would be equivalent to. So you guys go ahead and do 1 through 10, identifying which would be the equivalent. Again, looking at your blue sheet. So for example, number 1, by your Pythagorean identity, what is cosine squared going to be equal to? So looking on your blue sheet, 1 minus sine squared theta. All right, so you guys go ahead then and take a few minutes and fill those out.